We have a test module here that we use in our training schools to demonstrate accurately how our hydraulic pumping system works. These hydraulic pumps are mounted right down in the chassis of the truck. So by bringing you in here, we can really show you how this is all happening. Let me begin by describing how we get the power from the chassis to the hydraulic pumps. From the main drive line on the chassis, we send horsepower into the PTO gearbox. This gearbox then, when we put it into PTO, sends the power to our main hydraulic pumps. This is the heart of our free flow pumping system. These two hydraulic pumps are two-direction variable displacement piston pumps. When we turn our concrete pump on, hydraulic oil flows from port A or port B, depending which stroke we're on. This helps the oil to flow directly from the hydraulic pump to the drive cylinders without any unnecessary valving or overheating of the oil. During each stroke, 10% of the hydraulic oil is removed from this closed loop system. This is done by the flushing valve located on the main pump. This provides an efficient way of routing oil from the closed loop through the oil coolers back to the hydraulic tank. Coupling these two main pumps that run the drive cylinders, we add the accumulator pump. This hydraulic pump operates the S-tube, thus timing the S-tube and drive cylinders perfectly for smooth pumping performance. Our ability to do this with an electrical signal minimizes the amount of time it takes to change stroke. This also helps with boom bounce and production speed. The last pump in this stack is our agitator pump. This hydraulic pump operates our agitator circuit, our water pump circuit. It also sends oil back through our automatic valve. This valve controls our oil that we use to cycle the pump. Now let's go to our boom pump. To operate our Putzmeister placing boom, we utilize a variable displacement hydraulic pump that's mounted on the front of the PTO gearbox. This whole package controls the entire concrete pumping system on your boom pump. Next, we're going to go to the actual free flow hydraulic block and show you how we electrically signal these two main pumps to make your pumping smooth as silk. Now I'd like to describe for you how Putzmeister's free flow hydraulic compact block works. This block is the heart of signaling how we stroke our hydraulic pumps to provide smooth flow and pumping performance. We all know that an electrical signal travels faster than a hydraulic signal. And with our proximity switches, we can precisely time our stroke change event. Let me describe to you how these valves work. When we turn the concrete pump on, we send an electrical signal to our cycle valve. This is located right here. It's a two-direction valve. With voltage rate comes on here, we send a signal to our main pumps. As our drive cylinders stroke, it comes up to the proximity switch. This changes the stroke to the other side of the coil. This is a timed event, and we're able to, in a split second, change from one stroke to the next. In order to aid that, Putzmeister has what we call a POH valve, or pushover hydraulics. During our stroke change event, we completely time an impulse of oil to the main hydraulic pumps. What that does is it throws our control servos over quicker, and that helps to speed up our stroke change. This really improves boom performance and pumping speed. When we want to reverse our pump, we simply turn on our reversing valve. All this does is change the timing for the S-tube and the main pumps to draw concrete back in the pipeline system. To efficiently control our pumping speed, we have our volume control located here, beneath the POH valve. We control our volume with an electrical impulse for variable flow from dead slow pumping to wide open. We also have a manual valve located at the back of the valve. This way we have complete control over our pump speed, either electrically or hydraulically. While we're stroking, we're changing the S-tube from side to side. That's been done with this S-tube valve. There is no electrical plug-ins on this valve. When we turn our cycle valve on, it sends a hydraulic signal into the cycle valve for the S-tube. This times perfectly our drive cylinder stroke change and our S-tube change. The S-tube is pressured by our accumulator pump that we talked about earlier. This stores high pressure energy to quickly change our S-tube. I bring this back up because our accumulator dump valve, located here on the end of the block, is used to control that oil. When we go to E-stop or open the hopper grate, we want to make sure that that stored energy is dumped to tank. That is done with this valve right here. A convenient pressure gauge is located so that we can ensure that this valve has dumped the pressure for the S-tube. The next valve I'd like to describe is our automatic valve. This valve serves two functions. It controls our control oil for the rest of the valves. This adjustment helps to ensure that when we stop the concrete pump, it stops. The other function that it has is our high pressure limiting valve. If we plug the pump, say a piece of concrete or a rock in the boom pipe, we will relieve the main hydraulic pumps so that we don't suffer a damage to the pumping system or the boom pipe system. That pressure relief is controlled right here. This entire system completely controls everything you see here for concrete pumping. With an electrical signal and a low pressure hydraulic signal, we efficiently move our drive cylinders and force concrete into the boom pipe system.